Hello everyone. In this video I would like to show some highlights, some concept highlight of the Python code sensor throughput. We are going to show all three versions here. So we use a single mini. You can see they have infrared sensor on the left and on the right, and then also in the middle. So these are IRSS-10 and these DMS-80 long-range infrared sensor. Before you use Python, and I found out from hard experience, you make sure you download a blank task program to the mini robot first. So basically just hang on, you just have to curly bracket, download that one because it had to be clear. The task memory section had to be clear. Next, you make sure you need to download the correct motion group. Every code that Python code that I provide, I specify, you have to use certain motion group. So like for example, the throughput basic code use smart avoider motion group, and I provided a custom motion file. So you found load it up, find the smart avoider motion group, and make sure you downloaded it. This step is very important because in Python, when you want to run a certain motion page, all you will know about it is just the number, like number 9, which exactly corresponds to the left-hand wave of the smart avoider motion group. Okay, I'm using the standard module, sys and time, and of course Edbot. The Edbot I'm using in the book is 5.2.0.1523. Step programming with Edbot. There's certain step you need to do. Make sure everything working okay. First step is import Edbot. Suppose you've done that. You need to create one Edbot client. Easy. Only one Edbot client. The Edbot people say that's the best way to do it, to be thread safe. So the command is to Edbot client, you do the localhost port 8080 because it's using HTTP call, and you connect. Once you connect it, and then you can use one robot or two or several robots. In the book, I'm using up to 2 mini robot, one named Zira and one named Zork. So here I'm using only one robot, so say robot 1 Zira. Of course, if you have Zork, you can have robot 2 Zork. And then what you do, you check the Zira string with the configuration that you've done of the type Edbot. And if something is wrong, we're going to set up system exit. And how you do that, hopefully you need to configure it correctly in the Edbot software you bought or when you get a hold of it. So this is my Edbot software. It has zip, Zira, and then Zira, Zombie, Zork. So I have several of them. We'll be using Zork and Zira. So all this have been done and everything correctly. Next step then, we use the method wait until active to wait for the control of the robot to establish. It had to go through Bluetooth and all of that, so it takes some time to do. And then once you get this, when you get up to this stage here, you're ready. Okay, so you can use the robot with the whatever method from its API. For example, say method is essentially the text-to-speech utility. You set the servo torque. 0 mean all, 1 to turn everybody on 100%, and essentially this is turn on all the servos. Speed from 0 to 0, that means all, 100 from 0 to 100%. So basically you set it up by invoking the robot name, so robot 1, which is also same thing 0, and you pass some kind of string that makes certain sense for that particular method. Set custom is brand new with the Edbot software that I'm using now. So this one here is essentially write a 0 as a 1-byte message to address 82. This will turn the motion LED up. That means when you play a motion page, all the LED won't be flashing. It's cute, but it eats up on batteries. or let's suppose you want to write motion page 6. You just use a method run motion, specify your robot, and just put a number 6 there. Happen to be ready post in this context, in this example. Accessing data. Accessing data is not available during any motion play, so need to keep that in mind. So there's several steps also. First, you use a method called getData. This getData can provide you a very big Python dictionary. It has overall information in there. So you see getData, you say into data structure, the structure called data, and in there have server name. You have multiple robots, it's gonna show multiple robot. The only thing we are interested in sensor data as the reporter subdirectory here. You see it there, it belongs to 0, and 0 belongs to all the robots that you maybe happen to be using. So how do we do that? So once you get data, which is very big overall dictionary data, you abstract the subdirectory reporter from that dictionary data. So you supply that, you say, hey, look for the key robot. I'm entering the information robot 1, which is 0 in our particular case, and I want you to pull out the subdirectory called reporter. Whatever you got, you save it into the object called sensor data. And once you got that, it's not over yet. You need to use more keys. For example, I have NIR sensor on port 1, so I have to use key 1. Port 1, the key port 1, push into sensor data, put out, and then I save in distant port 1. So distant port 1 is just standard Python variable that would have the value of the sensor from port 1. If I want to access some kind of servo, like for example servo 1, of course the servo will have multiple parameters, position, speed, whatever. So I want position, so we have to feed in servo 1, feed in position, and then I got my position for the servo 1. Data acquisition approach. So once you get that, you can see that I get data, I got the structured data. From the data structure, I pull out the smaller dictionary I call sensor data. And then this is a very defensive programming here. I'm checking to see if the key port 1 exists. If it is, and then I pull the data out and I print it. Same thing if I'm looking to see if servo 17 exists, and I pull that information out, the position of servo 17, get it out and print it. And then this is very important. The data coming through the Edbot server tool is kind of slow. Sometimes you need to time sleep maybe 0.1 every cycle that you can get the data from the robot. This is all because of Bluetooth, and it's restricted to a baud rate about 57K, so it's kind of slow, okay? So watch out for that. Approach 2, because you building the robot, all the port and all the sensor, servo anyway, so you can pretty much skip all the if, save you some runtime, millisecond or microsecond there. So if just use it. Of course, at your own risk. If somehow the server goes wrong, something, and then that's something different. But usually pretty safe here. Approach 3, you can more professional. This is what the Edbot people use in their own code. Is you will do a try block with exceptions. So everything that you want to program inside the try block, and then here I'm monitoring for keyboard interrupt and keyboard error. So if somehow the robot 1, in the example later I show you, the robot 1 what first is defined as 0, and then later I suddenly inside the code I change to spot, therefore it doesn't exist in the Edbot database, so it's gonna fall on this key error. You see in the example run. And very important, you use Python the first time around, let's remember that before you run any Python code that I provide in the book, You make sure you run the Edbot software, the driver, bring it up. Make sure you connect all the robots that you plan to use in Python, so connect them first. And make sure that they are connected before you run the Python program. Like this example here. I'm using Zira and Zork in this particular time. You see I click on Zira, 5 seconds, and then 6 seconds I push on Zork to connecting, and Zira connected right away pretty well within about 5 seconds after I push it, but it won't connect to Zork for whatever reason. So you can see I had to turn the power off to Zork, turn the power back on again, and trying to reconnect it again, and within 2 seconds it connect good again. So at that spot here, around 16, 19, 25, Zira and Zork are both connected through the Edbot server. And everything fine, so I run my software, and both of the bots runs okay until time 16:21. For some reason, Edbot refused connection to Zira. At that time, what you realize is somehow Zira doesn't want to work anymore, and Zork was still working. So that's something you need to watch out for. Hello everyone, this is a demonstration of the Python code Sensor Throughput Basic. We have live video of the robot here, and Zira is connected to Edbot fine. So we're going. Starting.
Reading sensors data from robot Zira.
Okay, so I'm going to block right sensor. See, the right sensor went to A310. I'm blocking the middle sensor, so 400, 700, these. I'm blocking the left sensor, so when to go 600, 700 here. So, very basic. Let's stop this one. Clear it. Let's go to the Sensors Throughput Basic No If. Area button. There's really no difference.
Reading sensors data from robot Zira.
Here we go again. See right sensor? It's fairly not that quick, but and then see. Yeah. And finally, let's try the one using the exception, the try exception block.
Reading sensors data from robot Zira.
So I'm doing all kinds of here. Count to 13. Still doing strong. Let's see if I can scroll down. Oh, good. Let's see. It go up to about count to 1001, so that's going to take some time. So I'm going to stop this. Clear it. And let's change it back to, let's do about 11 only. We know how it works. And Zira is still connected. Very good. We'll try it again. Basically, Zira and a counter equal 11, it becomes spot. And
reading sensors data from robot Zira.
So Edbot will have problem reconciling the name of Zira to spot, and it will stop. It will throw an exception. 6. And 10. Here we go. Let's stop. And it trace back, and you can go, this is Edbot people code. You can see they did it well. It's inside Edbot client.py. So they took care of it. When they have an exception, they announce you there.